This is lesson 4-2, Intro to Exponential Functions. Our learning target for this lesson is that I can graph an exponential function using a table. So we're first going to start out just talking a little bit about exponential functions. We're going to look at the standard form of exponential equations. Just a little bit of review, we've had a standard form for each of our parent functions so far. For our linear, remember that it was ax plus by equals c. For our quadratic, it was ax squared plus bx plus c equals 0. And our standard form for exponential equations is going to be y equals a times b raised to the x power. And what those values are going to stand for, a is going to represent our start value, and b is going to represent our growth factor. If you remember back to our sequences in our last lesson 4-1, the growth factor is going to be very similar to your common ratio from your sequences. As always, x will be our input, our x value, or our domain, and our y will be our output, our y value, or our range. So let's go ahead and move on to the next slide. So we're going to have two real types of exponential functions that we're going to focus on. We're going to look at when a graph has an exponential function that is increasing and when it has an exponential function that is decreasing. And we can tell whether it's going to be increasing or decreasing based upon whether or not our b value is greater than 1 or if it is between 0 and 1, if it's some sort of fraction or decimal. Now, when b is greater than 1, our graph is going to be increasing. When b is between 0 and 1, our graph is going to be decreasing. Alright, so what we want to do with this lesson is to use a table to familiarize ourselves with some of the behavior and the basic characteristics of these types of functions. So what we are going to do is we're going to go ahead and graph a couple functions. We're going to use a table similar to when we start out with graphing linear functions and quadratic functions. And we are going to just plug and chug values in to help us get an idea of where this graph is going. So, our first equation that we're asked to graph is y equals 2 raised to the x power. Now, I'm just going to start out with some values. I'm going to fill out some values. These are some good starting values for when we are doing an exponential function. You may find that you might need to go to different values, but these are a good place to kind of get you a start. And we are going to plug those in to our function up here to get y. So if we plug in on the first one, y equals 2 to the negative second power. Now if you remember all the way back to 1-7 when we were doing properties of exponents, to get rid of a negative exponent we move the base to the bottom, so we'd move the 2 to the bottom, and we would make the exponent positive now. So that's 1 over 2 squared, which would be 1 over 4, which is 1/4, or 0.25. So we would go ahead and we would plot that on our graph. We go over -2, and we go up about 1/4 of the way, and we're going to estimate that that's about where 0.25 was. Now we would go ahead and do this for our other values. We would plug in 2, and then for instead of x, we're going to put -1 this time. So we're going to do 2 to the -1. Again, with a negative exponent, that's going to bring it to the bottom and make the exponent positive. 2 to the first is 1, so y is going to be equal to 1/2. So we are going to do a point at -1, 1/2. So you can see we're going up. Alright, and I'm going to put 0.5 here as well. Now if we plugged in 0, y equals 2 to the 0 power. Remember our exponent properties, anything to the 0 power is 1. So 2 to the 0 power is going to be 1. So we're going to have a point at 0, 1, and you can see your graph is gradually increasing. And the tip that's going to give this away remember if we had y equals ab to the x, if b was greater than 1, which in this case it's 2, we're going to be increasing. So we know we're on the right track. Let's keep plugging in values. Y equals 2 to the first power now. 2 to the first is going to be 2. So we're going to have a point at 1, 2. We're going to plug in 2. So y equals 2 squared. So y equals 4. So we're going to plug it, point in at 2, 4, and you can see we're starting to increase at a faster rate now. That's going to be one of your characteristics of an exponential function, is that it's going to start to increase or decrease pretty rapidly. And I will fill in my chart over here. And finally, we're going to have 3 plugged in. So 2 to the third would be 8. So we're going to have a point at 2, 8. Or sorry, 3, 8. And we're going to graph that point. We're going to graph that line. And this is going to continue to go up. Now, one thing that's going to be interesting, and we'll talk about this a little bit more as we go on, but as we go this way, what we're going to find is that since we're taking 2 and we're raising it to an exponent, anytime you raise something to an exponent, you're not going to get a negative number. So what this is going to do is this is going to continue to go closer and closer and closer and closer to your x-axis, and we're going to call that an asymptote. And we'll talk more about what asymptotes are. We've talked about them very briefly earlier on when we were talking about characteristics, but we're going to really focus on them a lot more in this unit. And what an asymptote is, and you can see this in your glossary, is it's a line that our line is going to get really, really close to, but never actually touch. This number is going to continue. This line is going to continue to go down and down and down, but it's never going to touch that line, and it's never going to cross that line. All right, let's go ahead and move on to the next example. So for example 2, we're going to graph y equals 1/2 raised to the x power. Now note this time that our b is going to be 1/2. So what do you guys think will happen with this graph? Is it going to be increasing or decreasing? All right, since b is between 0 and 1, this actually is going to be a decreasing graph. All right, so I'm going to go ahead and fill in some of my start values. And again, these are not perfect values. You might need to go a little bit bigger, a little bit smaller, but these kind of give you a starting point for graphing these exponential functions. We go from -2 to +3. And I'm going to plug in again, y equals 1/2 to the -2. Now remember, with our negative exponents, we flip the base. So this is going to become a 2 instead of 1/2. And now it's going to be to the second power. So y is going to give you 4. So we're going to have a point at -2, +4. -2 up, 1, 2, 3, 4. Alright, so right now I want you to go ahead and pause the video, and I want you to go ahead and plug in those values and fill out the remainder of our chart. Alright, now that you've had a chance to work those out, let's go ahead and look at what you should have gotten. You should have gotten -1, 2, 0, 1, 1, 0.5, or 1/2, 2, and 0.25, or 1/4, and 3, and 0.125, or 1/8. If you have any questions about how we arrived at those, go ahead and let us know. We'll be glad to help you out. Alright, so I'm going to plot these points. I have a point at -1, 2. I have a point at 0, 1. I have a point at 1.5, 2.25, and 3.125. And you can see we're getting close to an asymptote again. Our numbers are getting really small, but they're going to stay positive, so we're never going to cross that line right there. So we are going to connect our dots. And this is a little hard to do with the tablet, so give me a break if it's not a perfect line. Alright, and this graph is going to continue to go up this way. And we have our rough sketch of our graph. Again, if you needed to find some other points to help you out, you could have plugged in values above this, like -3, -4, or you could have kept plugging in values 4, 5, 6, 7, etc. Alright, let's move on to our last example. Alright, so our table did not get copied onto here, so I will go ahead and fill one out for us real quick. If we have x and y, we're going to start with those same values, -2, -1, 0, 1, 2, and 3. And we are going to need to plug into these again. So we would do -2 times 1.5 raised to the -2 power plus 3. And we're going to find out that this is not going to come out exactly. This is going to come out to be about 2.11. So we're going to fill that out. Alright, again, I want you to go ahead and pause this video and go ahead and fill out the remainder of the table for us. You might get some numbers that aren't so pretty, kind of like our 2.11. That's okay. And we'll check back in just a second to see what you got. Alright, now that you've worked those out, let's check it out. For -1, you should have gotten 1.67. For 0, you should get 1. For 1, you should get 0. For 2, you would get -1.5. And for 3, you should get -3.75. Alright, so next we need to plot these. So I'm going to have a point at -2, 2.11, so that's going to be just a little bit above 2. Again, we kind of have to do a little estimating there. At -1, we're going to be at 1.67, which would be about 2/3 of the way between 1 and 2. We have a point at 0, 1. We have a point at 1, 0. We have a point at 2 and -1.5. So we're going to go halfway down between -1 and -2. We're going to go 3 and -3.75. So we're going to go down 1, 2, 3, and part of the way to 4. Now we still don't have a real perfect clear vision of what we are seeing here. It looks like we might be approaching an asymptote up here, but I can't really be for sure to really draw my line solidly. So what I want to do is I want to go ahead and extend my chart to go up a little bit further to see if we can get some more values out here. So I'm going to just try plugging in -3, -4, and -5. And when I do that, I'm going to find that I'm going to get 2.4074, 2.6049, and 2.7366. So it doesn't look like we're increasing that much as we're going that way. So what we're going to see, and we'll look at some evidence that will further back this up in later lessons, but we're going to have an asymptote around 3. So I can use that to help guide the rest of my line. So I'm going to go ahead and connect these. We're going to keep going that way. We're going to draw this line so that it's going to have an asymptote at 3. Now, if we go back to our very first slide, or second slide, we had said earlier that when b was greater than 1, our graph should be increasing. And when b was between 0 and 1, it should be decreasing. If we go back and look at this, we had a b of 1.5. So that should have told us that we should have been increasing. Now, we did graph this correctly. The thing that is throwing us off right now is this negative sign that's out in front. When you're multiplying by a -1, what it does is it flips the graph over the x-axis. We'll talk more about that in Unit 5 when we get to transformations. But for now, just keep in mind that that negative sign will kind of throw that original rule that we talked about off a little bit. So just be watching out for that as you go through graphing these. Alright, there is no application for this lesson. Complete your practice and begin preparing for your mastery check. Let us know if you have any questions. See you next time.